All right, here's a bunch more information about vectors. First thing we have is we have parallel vectors. Okay, parallel vectors are just like parallel lines. Okay, if you want to think of them having the same slope, that's exactly kind of what the concept is. The direction and the magnitude does not matter though. Okay, so all of these A, B, C, D, and E are all considered parallel vectors. Equivalent vectors have the same magnitude in the same direction. So if I look at these 5 vectors, the only 2 that are equivalent are A and C. So A would equal C. If the vectors are opposite, they have the same magnitude. So B and D, even though they're opposite directions, they're not actually considered opposite vectors because they have to have the same magnitude. They have to have the same length. So the same magnitude in opposite direction. So A and E, so I could say that A is equal to the opposite of E. Those would be opposite vectors. And I could also say that C is opposite of E. Okay. The resultant vector is the result of adding 2 vectors. And there's 2 ways that you can do this. The first one is called the tip to tail method. So however many vectors that you have, you start with the first one, and typically it's started in standard position, okay? But I just gave you a vector A, and we put the tip to the tail, and then the resultant vector starts from the very beginning and goes to the very end. So this would be A plus B, okay? This is called the triangle method. The other one, you have the same 2 vectors, but you put them tail to tail. So I took A, and I didn't use a protractor, so you'll just have to bear with me here, but I took A, and then I took B, and I put them tail to tail. What this does is it's the parallelogram method. And so what we do is we draw in the rest of this parallelogram, and then your resultant vector goes here and is the diagonal of that parallelogram. So this is the parallelogram method. They both have their place. This is typically what people use. This is a little bit easier, but sometimes problems are set up already for you and they're already set up tail to tail. And so rather than moving things and doing things, sometimes it's easiest to just do it that way, okay? The 0 vector or the null vector, it has a magnitude of 0 and has no specific direction. Okay, so it's just kind of like in math when we have the number 0, we still need some kind of a placeholder. So there is a 0 vector. Multiplying by a scalar. Multiplying by a scalar does just what you want it to. So if I have a vector, and we'll call this vector A, if I want to multiply by 2, 2A is going to be twice as long, and it's going to have the same direction. So again, you'll have to bear with me because I'm not going to take the time to use a ruler on this, but if you look, it's about twice as long. If I multiply by a negative, okay, the length is still going to be twice as long, but the negative changes my direction, and so my vector is going to change direction. So multiplying by a positive scalar just makes it longer. Multiplying by a negative changes the direction, okay? And if I did a fraction, if I did 1/2, it's going to make it half as long. So we'll go like this, and we'll say 1/2A, okay? But the direction does not change unless you multiply by negative, and then they're all still going to be parallel.